Right, so the first thing that we are going to look at is some consideration regarding render time. So things that we can just do in our workflows that's really not going to require any extra work from us, but just some things to watch out, which I've discovered, if you want, the hard way in this working on this project. So let me just get that a little bit wider so that that's the default field of view. Okay, so two things really. Here we have the facade elements. So just going to show you quickly the typical workflow that we would have, on a project like this. This is modeled using a sweep modifier on an editable spline, which has disappeared because my shapes are hidden. So hopefully we can see it now. Okay, so that's an editable spline with a sweep modifier, which gives us this shape, this facade element, all in one large mesh, which covers a number of meters on the ground. Now, the way this works with Unreal is that it's not very efficient in the way it's going to calculate the light mass around and bake it onto this object. Is going to be the way I see it is that the light mass is going to have to interpolate between the illumination at this point and at this point, and bake all sorts of different, very different levels of illumination onto that entire object. The same thing goes for this long element here, this rail that was going around. So how did I find out which elements to optimize? So we'll go into that in a minute, but first I need to tell you about this tool, which is found on the build button, and when you place that little arrow, and you click on lighting info, you've got this lighting static mesh info, okay, which gives us this statistic window, which you can actually also have going to Windows and going to statistics. So this is a very, very, very useful little window to pay attention to, because you see here static mesh lighting info. It's actually giving you the size of your textures, and you see here you can order them by in size or increasing how to have all the biggest on top, and you can see that these elements have got the largest memory size, largest texture size in memory, and which is also quite useful. You can actually just click on them and the software will take you straight and frame them in the window so that you can have a closer look at them. So that's a really useful debugging tool. Now, the place that I want to highlight is the lighting build info here. So you see there's nothing in this window. So in order to show you what's in here, I am going to show you yet another project which I've pre-opened. And here I've done quite a clean render on this, and I've used the production level. Not that's too relevant, but I've done it using my network rendered using the swarm here. So that was only a few minutes, which is really encouraging to have such a clean solution here. Anyway, the reason I've done that is to show you this lighting static mesh info here, and when I go to lighting build info, after he's done a fresh build of the lighting, then you will see exactly how much each element has taken to render, and you can see that some of them are in the range of the hundreds, and some of them are in, this one took only 2 seconds, and this one took 400 seconds. So that's a lot, and that makes sense because, for example, these shelves, I've probably upped the light map resolution quite high, or they've got a lot of more light bouncing around them. Okay, so that's what this button does, and what happened with in this project, that these elements were when I was able to inspect after a build, these elements were taking very, very, very long time. Maybe it's because of the size of them, but they were taking sort of, you know, I think this one was sort of in the 19,000 seconds, compared to a few hundred for most of the objects, and maybe a couple of thousand for the most demanding objects. These ones were taking a huge proportionate amount of time, and so were these long rails as well. So the way to deal with this is, first of all, this is very simple. For these long rails, you would do that in your UV mapping, making sure that, so let me find that, making sure that there are no long sort of L-shaped elements. So all these will be broken down into smaller, I don't know if I can find one that's better illustrates my point. Maybe this one. Another rail here. UV channel 1. Yes. So you see here, there's no very long UV, and these have been broken into smaller pieces here. So the way you do that, so let me go back to my 3ds Max. So the way you do that is with your unwrap. So if you have some which are not broken, for example, well, I've only got this handy. You just select which you want to break up. So here they've all been broken up, and you just right click and you go break, and then you can move them and rearrange them. So that's the way to break these long rails into smaller bits, and then when you rearrange, they just come into like that. Okay, so that's pretty straightforward. Hopefully that's clear enough, because the big one was really, how do we deal with these very, very long facades, which would normally be dealt with like this in V-Ray, which really does not create any problem. So the way I did it was to, well, break them down into each one of these elements. So it was a little bit of work, and it was a completely different way of modeling, but I thought actually it makes sense, because these panels would actually be probably manufactured this way, and would be possibly in the future relating to some BIM element that could be related to a database in time. So maybe this is not the way we would do it straight away, referencing each individual element in a facade like this, but if it comes from a Revit model, most probably would be, and I think it's good practice to maybe start changing the way we model. Now, also the interesting thing is that between all of these mullions, the internal of the courtyard, the ones on the facade, these ones here, we've only got 5 different objects to import. All these are instances of, so the ground floor ones were a little bit taller, and then we had some issues of not them being exactly the same, because this was a project that was done fairly quickly, I guess, for it was for competition, so it wasn't actually completely specified. So, but it's interesting to note that this is a very, very efficient way to manage everything, and we can obviously have maybe higher light map resolutions when we work this way, and I think it's good practice to use the power of Unreal to create large amounts of instances and to deal with that very, very quickly. So this was really the two main bottlenecks. So when I sort of went to use this lighting static mesh info and check this after a light build, and you can really see very, very quickly how this is distributed around all your different objects. It's very, very good to optimize. Okay, so I hope that was useful, and let's move on to the next.